All right. Today we are doing tangents to circles. A tangent to the circle is what we are adding to our knowledge today. After we learned how to determine the equation of a circle and also to find the radius of the circle and the center of the circle depending on the type of equation you're given, we also want to learn how to determine the tangents to the circle. So for us to really get what we want to talk about, let me remind you a few things. Let's say we have a circle like this one, and then we have a line such as this one, which is only touching the circle at one point. Such a line is the one that we call a tangent to the circle. So it has to touch just at one point, then it can be a tangent. And we have other lines that may look like that. We will see those lines as we go. Those will not be tangents. This, in fact, we learned that it was a secant. Then we have chords, we have those type of lines, but we are going to only focus on the tangent today. The one thing I want you to remember mainly is that the tangent, if we have the radius somewhere here, let's say that's the center, this line that is from there to the center of the circle, we know that the radius and the tangent always meet at 90 degrees. So those are the things we want to remember, and we use that one in our Euclidean geometry. We said the tangent is always perpendicular to the radius. This is the reason we were using back then. So what we want to do in this situation is that if we have the gradient, this is what we're going to be interested in mainly, the gradient of the tangent, and this time let's say the gradient of the radius. Because we're doing analytical geometry, gradient is very important to find, and the relationship between these two is already well known to us. We know that if lines are perpendicular to each other, the gradient of the product of the gradient of those lines will certainly be equal to -1. So this is a fact we are going to use a lot, mainly to determine the equation of the tangent. If it is not given, we're going to use this one to determine its gradient. And of course, after we find the equation of the tangent, we may use it to find other variables that may be asked in the question. So, in fact, let's get going. Let's see it in real life and working with this formula and this fact here and see how it is done when we're answering questions. So I actually put these questions here in advance, so you may want to copy them down quickly, and then we're going to talk about them in just a few seconds. Okay, so here is what we have. The question is saying, determine the equation of the tangent to the circle which touches the circle at this circle here at point 1, 1. So that is what we want to do right now. We want to answer that one in C. So the first thing I'll encourage is for you to visualize it. Try to draw the circle and see if you can get some of these things right. So you have your circle. You know that if this equation is like this, I think you can determine that the center of such a circle will be at 2 and -3. That would be the coordinate of the center. And r squared is 17. It means r is going to be the square root of 17. Interesting. All right, so if we have that, I can put this one over here, and that will simply be the center. That will be 2 and -3. That's the center of the circle. A point 1, 1. So it will be to the left of this one and above this one. So let's just put that point over there. So this is the point that they are talking about. They are saying there is a tangent that passes through that point like this. And here is the coordinate is 1 and 1. We want to determine the equation of this line, the tangent. So we are not going to worry ourselves that much in this situation. It's just a short process that we have to obey here. Notice this is the radius. It is definitely going to be perpendicular to that. Those two lines are perpendicular. So on the tangent that we want, we know that if we have to determine the equation of a straight line, this is what we may want to do. we have to find the gradient of that straight line and also C, which is the y-intercept. We need a coordinate to do that. Normally, if we don't have the angle of inclination, we would need two coordinates to calculate the gradient of a line. In this situation, if you look on this tangent, we only have one coordinate. So it means we have to actually use a different method to calculate the gradient of a tangent. That is when we focus, we divert our attention to the radius. In fact, because we know that there is a relationship between the gradient of these two lines, it'll be fine if we can calculate the gradient of the radius first before we calculate the gradient of a tangent. So this is the formula for gradient, not just of the radius. In fact, let me do that. And then the gradient of the radius is going to be, why don't I say minus 3 minus 1, or 1 minus 3, doesn't matter really. Okay, and then 2 minus 1. So as you can see, the gradient of the radius here, if we are looking properly, we should get negative 4 as the gradient of the radius. So the gradient here is actually equal to negative 4. So to get the gradient of the tangent, we have to remember this. Gradient of the tangent multiplied by the gradient of the radius is equal to minus 1. We talked about this already, why it is so. Right? So if we want to determine the gradient of the tangent, this is normally how we will do it. But you will notice that after some time, I will not go through this. We usually just say the negative reciprocal of the other gradient so we can get to the answer quickly. So this is the gradient of the tangent. So now that I have it, I can use it now in this line, and I'll say, well, this is where we are so far. If I want to determine the equation of the tangent now, that is the gradient. But I need one coordinate that I can substitute so I can get C. And luckily for us, we have this 0.11. So what we're going to do is to make substitutions. And of course, 1 minus a quarter will simply be 3/4. So from what we have gathered, the equation of the tangent will now be 3/4, rather the gradient is 1/4 actually, and then the C value is 3/4. So this will be the equation. Normally they ask you to write the equation in form y is equal to mx plus c. So if you are like me, always always ready to do stuff like this, always check if the question is allowing you to go here. Most of the times they want you to just stop right there. No need to multiply by 4. Well, that is what we can do for that one. It's very simple. Calculate the gradient of the radius. Know that there is a relationship between the gradient of the radius and the gradient of the tangent, and then use that. So let's see what we can do with number 2 as well. Oh, that one requires quite a bit of space, so I am going to erase this one here first. Or rather, while you're copying, let me just copy that as well here. Right. We want to find the equation of the tangent at that point. But at this point here, we don't know where the center of the circle is. So if you want to calculate the gradient of the radius, you may want to know where the center is at. So this one is that place where you have to find the coordinates of the center first and then carry on with your work. So we already know how to do it, so I'm going to just remind you. Remember, we separate them, the terms with x and then the terms with y. Then you put numbers to the other side as well. What we said yesterday, or was it actually a few lessons ago, we said that b over 2 squared is what we is how we get the third term. So it's going to be minus 2 divided by 2, and you square that one. So of course you get 1, and then you should get 1 there as well. Here your b is 4, so remember it's b over 2 squared. So it's 4 divided by 2, and you square it. You should be able to get 4 as well. So that is what we have over there. And this step where we actually complete the square, remember we just say b over 2 this time. we don't square it. So you get x minus 1, the scale you already have, and then it's y plus 2, and on the other side it's 10 actually. So this is what we've got. So we can tell now that the center of this circle is at 1 and negative 2. And the radius of this circle is root of 10. Not that we may need it. In this situation we may not. But we do need the center of this circle. So now that we have the center of the circle, like I said, you don't have to really draw the circle, but I find it easier to talk about it when I can see where the circle is and everything else. So I am going to do that. Let's draw this circle. Let's say this was the circle. Okay. It looks like a circle. So the center, let's just put it at 1 and negative 2. That's the center of this circle. We want to find the equation of a tangent at minus 2, at negative 2, negative 1, that coordinate. So negative 2 should be to the left and negative 1 above. So again, the point is somewhat there. So that's the point. So the tangent still looks more like this. This is what I'm expecting. I'm expecting a tangent with positive gradient in this situation. Okay, so this is what we have. So let me see if you remember what I said. If we want to determine the equation of a tangent, yes, you're right. I think you figured you have to find the gradient of the radius first, especially if these two coordinates are there. So to get the gradient of the radius, you just say y2 minus y1. Let's do it the other way around now, so you can see that it's possible to do it whichever way. Minus 2 minus 1 minus 2, and then minus 2 minus 1. So this will be the gradient of the radius, and as you can see, it's minus 1 plus 2. That should be 1 over negative 3. I prefer writing that one as minus 1 over 3. That will be the gradient of the radius. Now that we have the gradient of the radius, like I said, you just invert and change the sign. That is the negative reciprocal. But for the sake of this lesson, I am just going to continue writing it like that. So if you want the gradient of the tangent, you can tell that it is equal to positive 3 just there. Now, equation, the gradient is 3, so the equation of a straight line, here we are, and we put 3 over there. Now I am substituting a point on the tangent, this one. Don't substitute that one, it's not on the tangent. This one is on the tangent. So you put minus 1, 3, minus 2 there, and since this is negative 6, if you take that one to the other side, hopefully that is so. So I'm going to write it as 3x plus 5. That will be the equation of this tangent over here. Well, I think you're getting the hang of what's supposed to happen when you want to determine the equation of a tangent. So let me throw in something interesting in this lesson. Otherwise, it's going to be too short. So let's write this question here. So in this question, I want to give you now the equation of the tangent. In fact, let's just write it like this. So if we have the straight line given to us, and the straight line has got an equation y is equal to minus 2x plus c. And we are told this one is actually the tangent to a circle. And let's find the equation of a circle. The equation of a circle is given to us as x plus 1 squared. And let's write that one as plus y squared is equal to 20. Something of this sort. And you are told that this is a tangent at point A, which is xy. There are two things that you'll be expected to find here. Let me say, firstly, if you are asked to determine the equation of the radius, so I'm going to just, so you have to find the equation of the radius. And then the other thing I'll expect you to find here is the coordinates of A and also also you should find that C. Let's also value of C. Okay, we cannot just phrase the whole question. So here is, let's see if you understand. We have a circle, that's the circle, and that straight line is a tangent to this circle at that point. We were not told the coordinate. So we want to try and solve those 3 questions that I asked on that question. So let's see. If you want, you can pause it and then try to work it out and then compare with what I would do and see what's what there. In fact, I actually want you to. Right, so here is what we can do. Firstly, determine, in fact, draw a circle. If you have an idea of what's going on, it's just to get. Draw your circle with center. The center here, I hope you can see that it's -1 and 0. That will be the center of this circle. And you have a gradient, you have a straight line with -2x plus c. That will be the equation of that tangent. You can see that the gradient is negative over there. Let's quickly find out what's what. So negative gradient is something of the sort. So I'm going to draw it over here so it can have negative gradient. Just put it over there. So this equation was given to be -2x plus c. So far that's what we know. And then this point is the point which is called A in this situation that we want to find. So we have a lot of things, and we also, the other thing we have, I think you can appreciate the fact that we have the radius, root of 20. Let me just write it as root of 20, although we can write it as rather 2 root 5 units. That will be the radius of that circle. So here is what we can do. Let's answer the first one first. Let's determine the equation of this radius. It's a good thing we already have 1 point. So it means finding C is not going to be an issue. However, we have to find the gradient first. And in this situation, it is the tangent that was given to us. The gradient of the tangent, you can see that it is equal to -2. So we know that the gradient of the tangent and the gradient of the radius is actually equal to -1. So you can find it like this. Okay, so the gradient of the radius in this situation should be 1/2. So now we know that if we want to find the straight line now, it is 1/2x plus c. This is the equation of the radius. So I substitute any coordinate that is on the radius. And in this situation, it is this coordinate. So y is 0 and x is -1. I think everyone can tell how c should be 1/2. So our equation becomes very simple. This will be the equation of the radius. Good for us, it's right here. Right? We didn't sweat that much there. So for B now, we have to determine the coordinates of A. Well, A can be seen as a point of intersection, as you can see, of the radius and the circle and also the tangent. I was going to use the radius and the tangent if I had the equation of the tangent. But at this point, I really don't have the equation of the tangent, so I have to use the fact that A here happens to be the point of intersection of the circle and the radius. Then I can use these 2 equations, that one and this one, right here. It will be a point of intersection of those 2. Again, one can think of using the distance formula. The distance formula will still give you this equation right there, so it's the same thing. So what I'm saying is, if we have an equation such as this one, plus y squared is equal to 20 as our equation 1, and use this one here as our equation 2, it does look like I can write it as 2y is equal to x plus 1. I just multiplied it by 2. I was going to use these 2 equations as they are. In place of y, then substitute this, but you know fractions. Fractions can be terrible, so we can avoid them. So I multiplied by 2. then I'm going to make x subject. It's easier to make x subject in this situation. Let me call that one our equation number 2. So what I am saying is, you can go and substitute equation 2 right into equation 1 and solve. Why don't we do that? So there, 2y minus 1, that's in place of x, then plus 1 squared plus y squared is equal to 20. I think you're following. So this is 2y only left, 2y squared, it will be 4y squared. 2y all squared will be this, and then that is y squared is 20. So it does look like 5y squared is 20 here. Y squared will be 4. Going to have to skip a few steps here, space. So y is plus or minus. If I divide this by, let's skipping steps is not working, plus or minus 2 there. So that is what we are seeing, because if you divide 20 by 5, you should get 4. So y is plus or minus 2. Okay, so in our situation, if we look at our coordinate A, you can see how it's only acceptable if we take a positive value for y. Y is 0 at this point, so if it's up there, we should take positive 2. So that's where our tangent is. And to get the value of x, I can use this equation right here and say x is equal to 2 by y, which is 2 minus 1. So it does look like x should be equal to 3, being so. So that is our coordinate of A. So we answered the coordinate of A. The only thing left is to find the value of C. So I'm not going to waste your time there. Let me find the value of C. In this equation here, the equation of that one, we now have a coordinate, so we can substitute it here like this. To get C value of, this is 6, if you take it to the other side, it should add to get us 8. So we can see how our C value is equal to 8. And now from here it gets interesting, because we are now going to do the examination type questions, but not in this particular video, in the other videos to come. Thank you.